Alright class, in this lesson we're going to take a look at the rational root theorem. What the rational root theorem does is it takes a polynomial, like this one, and it allows us to find all possible roots, and then later actual roots, of it. Previously, we've been taking polynomials like this and we've been given either a factor, like x minus 3, and saying, oh, this is a factor. In other words, in synthetic division, you'd have a remainder of 0. Or we've been given something like 5 and said, oh, this is a root or a solution or a 0. Okay. Well, now we're not being given that information, and that information didn't work for this polynomial anyway. What we're supposed to do is actually list possible roots, and then later we're going to try them to see if they work using synthetic division. So what we need to do is understand the rational root theorem says you're supposed to have all the factors of p and divide them all by factors of q. Well, p and q, p is your last coefficient and q is your first or leading coefficient. Okay, so what that means is that 12 here is p, and 1 is our q. Okay, so what we're supposed to do is take all the factors of p, which would be plus or minus 12, plus or minus 6, plus or minus 4, and plus or minus 3, plus or minus 2, and plus or minus 1. So those are all the factors of p, and then divide them all by the factors of q, which is just plus or minus 1 in this particular problem. But what we're supposed to do is, if there was more things, like if there was a 2 and, I don't know, some other numbers, we need to take each one of these numbers on top and divide them by each number on the bottom. But this time, there is not any other numbers other than just 1 on the bottom, so we don't have to do too much work. We just take our 12 and divide it by the 1, our 6 divided by the 1, and so on down the line. So what that means is that each one of those are over 1, so really it's just going to result in plus or minus 12 over 1, plus or minus 6 over 1, and so on. But that'll all reduce to 12 plus or minus 6 plus or minus 4 plus or minus 3 plus or minus 2, and plus or minus 1. Okay? So those will be your resulting possible potential factors for this polynomial up here. Okay? So I said factors, I mean roots. These are your possible roots that we could try in synthetic division. So now in the next problem, we're actually going to take a look at finding all the possible roots and then actually seeing which ones are the actual rational roots, and we do that using synthetic division. So again, let's check out using our formula here. This factors of p over factors of q, so our last coefficient divided by the leading coefficient. So this time we've got 2 is our p, 6 is our q. Okay, so we've got to take our 2 plus or minus and all of its factors, which would be just 2 and 1, plus or minus 1, and divide them by the plus or minus 6 and all of its factors, which would be plus or minus 3, plus or minus 2, and plus or minus 1. So this one has a little bit more work because I need to take each one of the top ones and divide them by each one of the bottom. Okay? So what that looks like is I actually need to rewrite this to be plus or minus 2 over 6, plus or minus 2 over 3, plus or minus 2 over 2, and plus or minus 2 over the 1. Now notice I'm not writing plus or minus on the bottom again because you only need one plus or minus. It doesn't do you any good to keep writing plus or minus. Now I need to take the 1 and divide it by each one of these ones on the bottom. So now I get plus or minus 1 over 6, plus or minus 1 over 3, plus or minus 1 over 2, plus or minus 1 over 1. Now, I know it looks like a lot, but it actually, some of these are going to cancel because we have repeats, we have redundant ones. For example, this reduces to plus or minus 1/3. The 2/3 doesn't reduce, so this is one root, this is a root. Plus or minus 2 over 2 is plus or minus 1. Okay, so that's a root, or a potential root, I'm sorry. Plus or minus 2 is a potential root. plus or minus 1/6. We already have 1/3, so we can just cross that out. We don't need it twice. 1/2 is new, and then this is going to reduce to 1, but we already have that, so we don't need it. So now let's just write them in order. So we've got plus or minus 1, plus or minus 1/6, plus or minus 1/3, plus or minus 1/2, plus or minus 2/3, and then plus or minus 2. So we've got 6 potential roots. Okay? So now here's the next thing. In the original problem, there's going to be 4 final roots. Notice I circled the leading exponent degree. This is the degree of the problem, the highest exponent, so highest power, actually tells you how many roots you have. So that equals how many roots. Now, that doesn't mean that they're all going to be real. It also includes imaginary roots. So you might have 2 real ones, 2 imaginary. You might have 4 imaginary ones. But most likely you're going to have some real ones. Okay? So the highest power tells you how many roots you will have. And maybe you've noticed that every problem we've had so far, when we did synthetic division, if there was a highest exponent of 3, there was 3 answers, maybe 1 real one and 2 imaginary, or so on. Okay? But anyway, what we need to do now is take these possible roots and try them with synthetic division on this problem using these leading coefficients. So let's go ahead and write these down here at the bottom, like this. And then what I'm going to do is you need to write your little box for synthetic division, and now we're going to start guessing and checking. With our potential roots right here, we need to actually try any of them right here in the box for our synthetic division. And now I know that's a lot of, that sounds like a lot of fun to just use trial and error, but I know it's not. What it will happen, and I guarantee will happen for pretty much all of your problems in the lab, is either plus or minus 1 will work every time, or plus or minus 2. So you won't have to go very far in the lab when you try these. You don't have to try each one of these fractions. The plus or minus 1 will work every time, or the plus or minus 2. Generally, the plus or minus 1 is going to work. So here we're going to try -1. So if I use -1, I go ahead and bring down my 6, and I get 6 times -1 would give me -6. And if I add those, that's going to give me 1. Now if I multiply here, that's going to give me -1. Add that, that gives me -13. And if I continue, that's going to give me +13. This will give me 10. This will give me -10. And I'd end up with -8. Okay. Now the goal here is to know that the final number has to be a 0. Since it's not a 0, I need to start going backwards and trying again. So I'm going to erase all this, and then what I'm going to try, instead of -1, I'm going to try +1. Okay? So let's try +1 this time. Bring the 6 down, and again, I'm looking to make sure that this number at the end, I'm hoping it's going to be 0. Okay? Because that means that I've found a root. So bring down the 6, times it by 1, and I get 6. Add those, I get 13. Multiply by 1, I get 13. Add, here I get 1. Times by 1, I get 1. Add those, I get -2. Times by 1, I get -2. And the result is 0. And that's exciting, that's great, because what that means is I found a root. So that means I actually kind of found a factor. This is a factor of x minus 1. Remember, this is really x equals 1, so if I rewrote it as a factor, it's x minus 1. So I found a factor of the original problem up top, which means if I now took my x minus 1, I could write it as a factor with what's left over here. These are coefficients of the expression. Fill in my x's, x squared, x to the third. So this is my new problem. I've got 6x to the third plus 13x squared plus 1x minus 2. This is a new polynomial that I could actually take and times by x minus 1, and that would give me my original equation, the original polynomial I started with at the beginning, if I was to actually multiply this out. I'm not going to, though. My next job is to go ahead and factor what's left over. using synthetic division once again. So now I take my coefficients, the 6, the 13, the 1, the -2, and I use synthetic division again. Well, I don't have to do the whole P over Q thing again because I still am working with the original problem up here, which has been factored now, but I still only have these possible roots. So now I'm going to jump over here and try this plus or minus 2 rather than play with fractions with my synthetic division. So I know that I already found that positive 1 works right here, and I already found that negative 1 doesn't work, so I'm not going to try negative 1. I'm going to go ahead and try 2. Okay, so now let's try 2. Bring down the 6, times it by 2, and I get 12. Add that, just get 25. Times it by 2, and I get 50. I'm getting way too big. There's no way that it's going to end up as 0 over here. So I'm just going to stop without continuing. So now I'm going to back up again. Instead of trying positive 2, I'm going to do negative 2. Okay, bring down the 6. Times it by negative 2, I get negative 12. It's already looking better. Now I get 1. Times it by negative 2, that gives me negative 2. Add that gives me negative 1. Times it by negative 2, it gives me positive 2. And that results in 0. So what that means is I just found another root. X equals negative 2 is my second root, which means that x equals negative 2 is my other root. So my factor is x plus 2. So I found that factor, which is a root of negative 2. And now I have 2 more to find. Well, it's not as hard now to find my next roots because if I backfill this is x to the 0 power, x to the first power, x to the second power. I just reduced my problem to a quadratic. Okay? So this quadratic now can be factored, hopefully with magic x. If it doesn't factor, then I have to do quadratic formula. So here I'm going to multiply my 6 and my negative 1, which gives me negative 6 on top, positive 1 on the bottom. So now what that means is I actually can factor with a 3 and a 2 if the 2 was negative. Now they multiply to be negative 6, they had to be positive 1. So this was wonderful because it actually factors by dividing by 6x. Dividing this one by 6x also will let them both reduce. This reduces to 1 and 2. This reduces to 1 and 3. So that means this factors to be 2x plus 1 and 3x minus 1. So I just found my last 2 factors, which means I need to set them equal to 0 to find the last 2 roots. So this will give me x equals negative 1/2, and this will give me x equals positive 1/3. So these are my last 2 roots, and if you look over back at our original trial, we do have our negative 1/2 as a potential root right here, and we have the positive 1/3 as another potential root. So those were actual roots along with our positive 1 and our negative 2. So those are our 4 actual roots that came out of my possible ones. Okay? Now it doesn't mean, so this is the end of the problem by the way, but it doesn't always work out that all 4 of them will be real. These are all our real possible roots. But even though we've got all these as potential roots using our P over Q thing, there is a possibility that in the end I could have had to do quadratic formula right here, and let's say that you ended up with like 2 plus or minus the square root of a negative. If you got that, what that means is you actually will end up with 2 imaginary roots. And that's fine. It just means that we had 2 real ones and then we would end up with 2 imaginary ones. So I'm just saying there is that potential scenario that you might have that where you still ends up to having actual 4 roots. It's just that 2 of them were real and 2 might be imaginary. So look out for that as you're doing your work, and good luck working out these problems. If you have any questions, go ahead and email me and I'll try to help you the best I can.